Unit 6, Rational Functions. What is the equation of the vertical and horizontal asymptote for the graph of f of x equals 2x minus 8 divided by x minus 3? So first, we're going to find the vertical asymptote, and that is where your denominator is equal to 0. Asymptotes are boundaries that are trying to stop you from dividing by 0, which is not mathematically possible. So we're going to take whatever factors in the denominator and set it equal to 0, and we're going to solve for x. And so our vertical asymptote is at the line x equals 3. For our horizontal asymptotes, that one depends on both numerator and denominator. So first we're going to look at the degree of the numerator, which is the highest exponent, which in this case would be 1. We're also going to look at the degree of the denominator, which in this case is also a 1. And we're going to compare. If it's top heavy, bottom heavy, or same, there are different rules. You can find your rules on your formula chart. So because the numerator degree and the denominator degree are the same, we are going to find our horizontal asymptote by dividing out the leading coefficients. So we will divide out the 2 on the top from the 1 on the bottom. So 2 divided by 1, which simplifies to 2. So our horizontal asymptote is y equals 2. 21. Which of the following could be the equation for the rational function shown? So this is basically going backwards from what we just did. We're going to start with the vertical asymptote. So in this case, the vertical asymptote is that x is equal to 4. So if we were to unsolve this, that means you would have x minus 4 in the denominator, which would leave us to get rid of c and d. Then we're going to look at the horizontal asymptote. And so we see that the horizontal asymptote is at y equals 2. So that means we must have a 2 on the top and a 1 on the bottom. This would be negative, this would be positive. So B is our correct answer. 22. Simplify the expression. So in order to multiply rationals, which are just fractions, we need to make sure that everything is factored. So we're going to factor the first numerator here, and that's a trinomial. So we're going to factor with our AC method. So A times C is negative 12, and then B is negative 1. So we need two numbers that multiply to negative 12, but also add to negative 1. If those numbers are going to be negative 4 times 3. If you add them, you end up with negative 1, but when you multiply, you make negative 12. Because A is a 1, we can factor with our cheat method, which means the numbers in our t-chart are our factors. So we have x minus 4 times x plus 3. Then the denominator underneath that one is already factored. X and 3 are stuck together. That is only two terms with no exponent, so that cannot be factored further. Then on the right side, x minus 1 is also done. That is factored as far as it can go for the same reason as x plus 3. And then we have another trinomial. So again, we're going to do the AC method. A times C is negative 20, and B is a 1. So we need two numbers that multiply to negative 20, but add to 1. That would be 5 and negative 4. So again, we can use our shortcut because A is a 1, so our factors are x plus 5 times x minus 4. Now that everything is factored out, we can start to simplify. So because we are multiplying, that means this is multiplied to this one, which is also multiplied to this one over one fraction, because that's how you multiply fractions. You just go straight across. Because anything divided by itself can be considered a 1, we are allowed to cancel the same factor top and bottom. So x plus 3 is the same top and bottom, and same thing with x minus 4. So the only thing left in the numerator would be x minus 1, and the only thing left in the denominator would be x plus 5. And again, because these are added to something, you cannot cancel the x's. So this is as far simplified as you can go. Solving for x. This is two fractions equaling to each other, which is a proportion. We can solve a proportion using cross multiplication. So we're going to multiply 3 times 3x plus 5. And that is going to be equal to the x plus 2 times 8. Now that your fraction's gone, we can simply distribute and solve like normal. So 3 times 3x would be 9x. 3 times 5 would be 15. And then you can distribute backwards using the 8 first instead of the x plus 2. Move your x's to one side with addition or subtraction. So we're going to subtract 8x from both sides. So we get x plus 15 is equal to 16. Move your constant to the other side with, again, addition or subtraction. And because there's no coefficient on x is equal to 1. Simplifying addition. So with addition of fractions, you have to make sure that you have common denominators. If you do not have common denominators, you cannot add or subtract fractions. So we need to find the LCD. That means we need to make sure that all of the factors in the denominator are accounted for. So the first denominator has x plus 3, and the second factor in the other denominator is x minus 4, which means the denominators of both fractions must have x plus 3 and x minus 4 in order to match. So the first fraction is missing the x minus 4, so we're going to multiply numerator and denominator by the factor that it's missing. We're allowed to do this because that is simply just a fancy form of 1. Something divided by itself is just 1, written in a different form. Then the other fraction is missing the x plus 3, so we need to multiply its numerator and denominator by x plus 3. So in the numerator, we can distribute. So 2 times x would be 2x, 2 times negative 4 would be negative 8, and in the denominator, we can simply leave it in just factored form, x minus 4 times x plus 3. Do the same with the other fraction, 5x plus 15 divided by x minus 4 over x plus 3. And we can see now that our two denominators do in fact match. So we are allowed to add the numerators by simply collecting like terms. So 2x plus 5x would be 7x, and then negative 8 plus 15 would be 7. And we can leave our denominator as x minus 4 times x plus 3. That is a perfectly acceptable answer. If you would like to factor out the 7 in the numerator, you would actually end up with the same answer because you are still not able to cancel out any of the same factors. So these two are both equivalent. One is not more simple than the other. Next, we are dividing fractions. So dividing is just another step to multiplication. So in order to divide fractions, we do a trick called keep, change, flip. Essentially, you're multiplying by the reciprocal of the second fraction. So we want to keep the first fraction exactly the same. So we're going to do x squared minus 5x plus 6 over x squared minus x minus 6. We're going to change that division to a multiplication sign, and then we're going to flip the second fraction. X minus 3 is now in the numerator, and x plus 6 is now in the denominator. And now we have a question just like the multiplication one from earlier. To make sure everything is factored and then cancel any common factors, numerator to denominator. So on the left, we can factor out x squared minus 5x plus 6 using your AC method. So we have a times c is going to be 6, and b is a negative 5. So we need what multiplies to 6 but adds to negative 5. 2 and 3 will multiply to 6, but if you add 2 plus 3, you get positive 5. That means we have the right values. To get a positive with multiplication, you can do a positive times a positive, or you can do a negative times a negative. Both of those will produce a positive answer when you multiply. However, when you add two negative numbers together, you actually end up with another negative. So negative 2 plus negative 3 makes negative 5. So these are going to be our factors for the numerator, x minus 2 times x minus 3. Then similarly in the denominator, we have x squared minus x minus 6. So we want a times c to be a negative 6 this time, and b to be negative 1. So now to multiply to a negative, you need one positive and one negative. If I want it to be a 1, I'm also going to use 2 and 3 again, but in this case, the 2 will be positive and the 3 will be negative. That way, when I add, the negative have more left over. So there are your factors for the denominator, x plus 2 times x minus 3. And then we still have the other fraction that cannot be factored in the top and bottom. And remember that x minus 3 are stuck together. Now that everything is factored, we can cancel the same factor top to bottom. I do see that there are 3 x minus 3's. However, I can only cancel out in pairs. So something divided by itself is a 1, not something times something over itself. That's not going to make 1. So you can either cancel those 2 or you can cancel these 2, but you can only cancel 2. I don't have enough to get rid of the other x minus 3. And then there's nothing else that is like. So in the numerator, we have x minus 2 times x minus 3. And then in the denominator, we have x plus 2 and x plus 6. We could not get rid of this factor because one's a minus and one's a positive.